Okay, we'll make a start. Good afternoon, everybody, and welcome to our Architecture, Mythology and Quality webinar this afternoon. This is the first webinar that we have run. We have a couple more coming up. One will be end of January and one will be end of February. Just to make you aware, we are recording this session and we will be hosting this on our YouTube channel after the event. I shall also let you know via email when it is actually up there. At the end of the webinar, you'll receive a link for a survey. If you could fill that in, that would be absolutely fantastic. So to start with, I'm going to hand across to Alexander to give you the first part of the webinar. I hope you all enjoy. Alexandra, over to you.
Thank you, Sarah. So welcome also from my side. My name is Alexander Kovarik. I'm from Statistics Austria, and as all of the presenters, we are working together in the project Web Intelligence Network at the moment. Before we start with the project, with the presentations, just 5 sentences on the project, so you also know a bit about the context. And you might hear some abbreviations like work package 2 or something like that during the presentations, so you also know a little at least what that means. So the Web Intelligence Network is organized in 4 work packages. The first one is, for example, organizing this training. So it is about competency building, user support, and engagement. The second work package is about online job advertisements and online-based enterprise characteristics and the implementation or making that ready for production. The third work package is about exploration of new use cases with the usage of web data. And the webinar today was organized by work package 4, which is called also Quality Methodology and Architecture, as the 3 topics in our presentation. So we will have, as I've mentioned, the 3 topics. We will start with architecture presented by Giuseppina Rocco. Then I will present the quality part, and after me, Pete Das will present methodology. So with that, I will hand over to Giuseppina and ask her to share her slides and start. Thank you.
Thank you, Alexander. Good morning, everybody. I am Giuseppina Rocco, and I work as a technologist at the Italian National Statistical Institute. Today, in this webinar, we will talk about the main goals of the Web Intelligence Network. Then we will explore the Web Intelligence Hub and the Web Intelligence services from the NSI's perspective. The main goal of the Web Intelligence Network is to support the web data collection and help all NSIs to collect and process web data. This goal is achieved through the development of reusable tools for collecting and processing web data. So, starting from available web data that can be used for several statistical purposes, the main goal of this intelligence hub, of this platform that is under development, is to provide several services for develop and put in the statistical production several use cases, starting from the previous SSNet Big Data 2. The first two use cases that will be put in the statistical production are online job advertisements and online-based enterprise characteristics, OBEC and OJA. These use cases have been developed starting from the results and the activities of the previous SSNet. That has another main result, that is a reference architecture that is BREAL, Business Reference Architecture and Layers. This BREAL, among the description of the different architectural layers, provides a set of business functions and describes the roles and the actors that are involved in the big data acquisition, processing, and exploitation. So this is the BREAL representation of the different business functions, and here we can observe that there are some overarching business functions, but starting from this reference architecture, OBEC and OJA use cases have been implemented as a set of workflow activities and components that are summarized in these representations. Here we have an internet access, web data storage, data preparation, and analysis. The same workflow can be represented for OJA, and this workflow, these data pipelines are connected with the BREAL business functions. But what is the perspective of NSI's staff dealing with web data? What are their requirements? How can they contribute to the platform, to the WE platform? We have distinguished for our purpose three main roles that are in every statistical institute: data scientist, researcher, and domain specialist. And within our work package, our task, our purpose is to approach the BREAL functions through the use cases in order to understand and allow the reuse and the standardization of process steps and application components. And how can we approach to these actors that are involved in building the WE platform? We have thought about three users' stories that have the main goal of enhancing the requirements of these particular users. So the three user stories we have imagined are using big data capabilities, harmonizing traditional and big data sources, analyzing statistical output from web data. In the first user story, a data scientist having a training dataset may access the WE platform to run a machine learning algorithm using data that are available in the platform. So the main tasks he can execute are, first of all, a selection of datasets and variables to process, a data preparation, the execution of the machine learning model, and the model assessment. And what type of data and metadata are needed to execute these tasks? First of all, the description of data structures involved in the process in order to select the data of interest. Second, we have imagined the relevance. We think about the relevance of tracking the main process steps executed to achieve process auditability and reproducibility, and at the end, a set of machine learning quality indicators. The second user stories concern a researcher. Let's suppose he wants to access the WE platform to run statistical methods and analyze the statistical output obtained from web data for several purposes. For instance, to enrich or reduce the information collected through traditional survey modes, test several methods, different methods for record linkage, for instance, in order to combine survey and web data sources, or provide an assessment of web data sources in terms of representativeness of the statistical population. Or he may highlight coverage issues that may affect specific subsets of units or some variables. So in this case, a researcher may use traditional data sources as auxiliary information. Which are the tasks that he may execute in the platform? Selecting, first of all, the selection of datasets and variables to process. Then he may explore data, the selected data, assessing data quality issues, or, for instance, compare the WE data with auxiliary available data sources. And also in this case, he may need, first of all, a description of data structures in order to select the data sets and variables of interest. The tracking of the main process steps is also needed in order to reproduce the process and assess whether there is some tasks to modify or to drop, and provide also at the end, it would be useful to have some indicators, quality indicators, for assessing the output of the applied methods. The third user stories regards domain specialists. In this case, an expert involved in the statistical production may access the platform for contributing to the data validation process. And through several steps, for instance, a benchmark of aggregated output of aggregated statistical output achieved through web data, and auxiliary data that are already available in the official institute, in the statistical institute. He may assess data accuracy in terms of coherence and comparability, or proceed with the manual revision of a statistical output to validate and improve the data pipeline. These tasks are summarized in the selection of datasets, records, and variables to analyze, and then the other tasks that can be performed by a domain specialist are data analysis and quality assessment, comparison with auxiliary sources, and manual revision. As in the previous user stories, we still need the description of data structures involved in this task, and also the tracking of the main process steps and the quality indicators for assessing the output of the methods that have been applied and the tasks that have been executed. From this perspective, so in order to build a we capability that can be used by different actors and roles within a national statistical institute, we need these roles to cooperate. So in the cooperation and in the sharing of the results, in the sharing of methods, and in the interaction between these actors, we can find a win-win strategy that will provide great results for all the members involved. I thank you for your attention, and I will be happy to answer to your questions if you have any. Thank you.
Thank you, Giuseppina. I forgot to mention that at the beginning, we will collect questions for all three presentations and try to answer them or discuss them after the three presentations. Please post your questions in the chat. I hope you all have access to it. So I will be the next presenter. So I also try to share my slides. Is that working? Do you see my presentation? Yes, thank you. Okay, so my part is the overview of the quality aspects. All three topics are, of course, connected, architecture, quality, and methodology. So there are alignments between the topics necessary, and also at some point, I mean, quality methodology especially are just two sides of one coin, or however you phrase it, so very, very closely connected. During my presentation, I will talk a bit about quality of traditional data sources in comparison to the quality of the new data sources, especially, of course, web data. Some examples of quality aspects, quality guidelines for web data. And as an example, there's already a document there, and some examples on different quality issues that are observed with this kind of data. So probably most of you are from the NSI world, so you know a lot of these traditional data sources. So we have quality dimensions, and there are also well-established, well-known quality indicators for these quality dimensions. So the quality dimensions are relevance, accuracy and reliability, timeliness and punctuality, comparability and coherence, and accessibility and clarity. And quality indicators we all know of is, for example, the unit non-response, item non-response rates, overcoverage rates, or for the comparability, the length of a comparable time series. So these are indicators that are known how to compute that, and that are basically well established and easy enough to compute. However, if you just look at the first example of unit non-response, it's quite obvious that if you look at the quality of new data sources, not all of them are applicable or needed. So the traditional quality dimensions, and especially also the traditional quality indicators, are not sufficient to cover new aspects of the production line, of the production process. So there's a need for new quality indicators for this work. The focus for us here is the access to data part and the throughput phase, the so-called throughput phase. We will see the data pipeline in a moment that describes them more closely. That connects to the BeReal functions of acquisitions and recording, data wrangling, and pre-processing. So that I also already said that. So response rates, for example, is something that are quite traditional, obviously coming from from survey product survey estimates, and are not really meaningful for this kind of projects. But other indicators such as the overcoverage rate is something that is transferable to the to these new data sources, to web data as well. There will be, or there are new indicators necessary which are not yet well established. For example, the duration of stable access to a new data source, or a duplication rate, for example, for the online job advertisements. Since the new data sources in general vary hugely, quality considerations should take the data class into consideration. And now we are talking about especially about the data class of web data. So we are not trying to be too generic here. We've tried to find some kind of middle ground to be to propose quality indicators, quality guidelines that are still directly applicable, but not just to one use case, but to one class of projects of data inputs. So this data pipeline, you see the picture that's taken from the online job advertisements data processing at the Web Intelligence Hub. We heard a little bit before about it. And what I'm trying to do now is to just go through it and see that basically their quality aspects more or less hidden in plain sight in all the steps. So if you do think about the landscaping, so which websites with the information you want exists, job portals, real estate web portals, and so on, then part of that can be accessed via an API, or has to be scraped with other means. Then the quality related aspect is especially if the access to the website is stable over time. So that you not just start scraping a website, produce statistics that after releasing the first time the website is gone, or at least your access is gone. And in this landscaping, it's of course important also which variables are available. During the ingestion phase, the data ingestion performance is affected by external elements, and they can fail due to various causes, technical causes like loss of connectivity, server errors, but also that the websites just changes the structure of the information. So it has to be constantly monitored if a process is still successful. In the pre-processing part, when merging different data sources, the duplication is a big problem, and the deduplication for OJA is there separated in 3 parts. So there's physical deduplication, semantic deduplication, logical deduplication. But there's also the coverage and selectivity. So also if you use several data sources, you only cover the online job vacancy market in this example, and the penetration of the online job vacancies in comparison to all the job vacancies will vary across countries, but it may and it will also change over time. And that's definitely to be considered and to be measured with quality indicators. In the information extraction phase, modeling and processing errors can happen basically when using ontologies, text mining, machine learning methods, all of them have errors associated to them. And the quality aspect then is basically data accuracy. So we kind of, with errors in the processing part, we come to misclassifications. So we, for example, with regards to the occupation or skills, geolocation or economic activity. So all of that are dimensions for which we want to build results at the end of the day for a specific statistic for this online job advertisements product. And all of them are not directly available. They have to be classified, and all of them can have errors, and it will lead to accuracy problems. So just shortly want to mention a document we already have produced and which is available in the internet with the link below. The minimal guidelines and recommendations for implementation, and I will just give a very small example on the quality part. So the throughput phase is also described there, and the quality aspects that are listed there, and taking a deeper look at linking, coverage, comparability over time, measurement errors, and model errors and process errors. And how the document looks like, how the guidelines looks like, is that we look at comparability over time, and two examples. So we have a kind of a guideline, so closely monitor the structure of the data, and then a more detailed explanation what we might mean with that. So in this example, it's check each data generation on structural change in comparison to the previous one. Another thing you should do with respect to comparability over time is continuous updating of the data acquisition and recording tools. Don't read the text here. So basically, the data source might change, and you constantly have to update your scraper to still record the data you actually need, and not lose some variables because they are moved in different places on the website, for example. So the goal is to scrape the data in long time series. Just listing the quality aspects we found, or just showing you quality aspects we found in the data with examples, and how they can be applied. Work package 3, so that's the explorative work package in a project with several use cases. They agreed on a kind of criteria list for the validation of a data source, so that there are mandatory variables. So variables web data source has to have to be used for a given use case. Obviously, it depends on the use case you are in, which the mandatory variables will be, but you should define a mandatory list of variables. And there's a checklist available for going through the quality assessment of each data source. And at the end, you can actually rank your data source, and might obviously in the example table at the left, you will not look at the ones with 0, but you can also kind of propose a cutoff value if the probably resources are limited, and if you have to implement scrapers for the website, you should start from the ones with the highest score. And there are stop criteria defined. For example, if there are blocking mechanisms in place. So, for example, a capture some robot blocking that you cannot just scrape. For example, the first 50 job adverts. If I stay with that example, then that's a kind of a stop criteria, because we will never get all the data you will need. Another issue that is quite prominent in several of the use cases, and if you work with in combining several web data sources, it will probably be an issue in most of the projects, is duplicates. So an example for that is from the use case on characteristics of the real estate markets. Moreover, one of the main challenges one must deal with regarding data is that all for the advertisements are uniquely identified. They are not unique in the sense that several ads may refer to the same offer and the same dwelling. And methodological analysis on the text have been undertaken to identify and remove duplicates. So of course, if it's a dwelling or if it's a job advert, it will not just be in one data source a lot of times, but it will be advertisements in several places. So a different node and similar issue. So employers often post vacancies on several job boards simultaneously. And how you find the duplicates in the case of online job advertisements, but it's already quite generic, I would say, is that checking the similarity of the content and also the publication date if it's published at a similar point in time. However, there's no empirical way of verifying how successful this process of deduplication is. And this example is also that the CDFOP, the agency that collected the data initially, was not able to reliably answer this question. Of course, this criteria, so to look for similar content and to look for publication at similar dates or the same time, helps. But as we know from experience that the same job ad does not have the same content in different portals. The structure of the portals is different, but also the target groups are different, and with that, the advertisement is kind of targeted to the audience of a specific portal by the HR units posting the job ads, so that it's not an easy task to fix that issue. Another issue is that's reoccurring is comparability over time, and one example for that is again about real estate portals, that the website is loaded with ads posted by realtors. That's a given, and recently individuals who do not want to use intermediaries for their real estate transactions are renting out. So that's describing kind of a change in the market basically, and that might hurt the comparability over time in this example. So if the data source is changing, of course, your estimates are changing, but in fact, the real estate market might not change, but just the mechanisms behind it. Okay, with this, I hope I gave some insights on what work we are undertaking and what considerations we are having with in terms of quality aspects. And with that, I will hand over to Pete Taas for the presentation on methodology. Pete, please go ahead. I will stop sharing the screen, hopefully.
Okay, thank you. I will share my screen. And I hope you are all able to see my slides. I hope you agree. This is the methodology part, and my name is Pete Taas from Statistics Netherlands. And I've created this set of slides together with Jacek Maslankowski, who is the leader of work package 3 of the SysNet on Win, and we both have a lot of experience in generic web scraping, and we try to combine everything. And the idea was, let's start with dealing with the methodological issues when you start with web scraping, so at the beginning of the process. So this is all focusing on collecting data. The outline of the presentation is I'll briefly introduce web scraping, talk about the population perspective, which is more challenging than it seems, how you get the URLs or the links to the locations of the web pages you want to scrape, and a list of scraping issues and how we have to deal with them. And it may take a bit more than 50 minutes, and I will end up with the concluding remarks. Web scraping, that's highly dependent on your IT environment, and this is a nice example of where technology and methodology interact. Depending on the choices you make on how you're going to collect the data, it might affect the data you collect, and in that way influence the methodological challenges you run into. And I'll discuss about web scraping in a generic sense, which means I have a list of locations on the internet, and I want to collect the HTML page to which those links refer to, and I'm not want to do any additional processing during that data collection. I just want to get the HTML page to which the link refers to and make a local copy of that, because that's in principle the most generic way of web scraping. What are the essential steps? If you look at it from that perspective, oops. The first thing you want to do is identify your target population, which in a BeReal function is specify the needs. This is the most important one, and you might discover that the topic of interest that you have, that web scraping is not the ideal way to deal with them. If you only notice that a part of your target population has a web page, then you have to find another way of dealing with that. But usually, if you choose your topic very carefully, you will have a large part of your population contains a web page, and we talk about businesses in this case. The second point is then you need to make sure that you have the URLs of all those units. So each company should have a specific URL where you want to refer to and collect the data. That you might need to update it. That's the data representation part. The third step is actually scraping the web page, or in essence making a local copy of your of the HTML page to which the link refers to. That's the acquisition part, and this includes checking the robot.txt file if you want to scrape very nicely, conforming all the rules. And this 4 point is just to indicate what the difference is between specific and generic scraping. If you do specific scraping, for instance, you're only interested in the price of a particular product on that web page, then you do some processing of the HTML code and only extract the description and the price. And that's the data wrangling part. But I want to exclude that as much as possible because it makes talking about the methodological challenges a bit easier. And the fifth step is actually saving the data page in a particular format. Might be a true HTML copy of a JSON file. That's the acquisition and recording part of the BeReal function. So that's web scraping. And it's important to think at the beginning of the population that you are interested in. Depending on the topic of interest, it might really be very interesting to start collecting data from websites. But it also affects the number of websites to be scraped. You don't have to scrape the entire web to produce some very interesting statistics. And together with Jacek, we came up with a very simple overview. Sometimes, if you're just using the web to obtain results from a search engine, you are only visiting one website. Or if you want to extract satellite pictures from a particular website, that's the only place you visit on the internet. So your web scraping is rather specific to a particular website. Depending on the topic, there might be more websites of interest, what is called purposive sampling. For instance, if you're interested in online job advertisements, then you try to create a list of interesting sites where there are a lot of online job advertisements, and that might be limited to 10 or 20 or so. It's the same is the case for real estate prices. And if you're interested in extracting prices, you might also be looking at, for instance, only supermarkets, or at least a limited set of them. The most interesting part is when you decide, no, I'm going to try to collect as much data as possible from the internet. I'm going to extract all the websites of my population of interest, which is, for instance, enterprises. And I will show you an example later on of enterprise characteristics study done by Jacek, where we try to extract information from all the web pages on enterprises in Poland. And I've done a similar study where we looked at the innovative company detection, and then the intention of the study is to collect all the websites for that particular population of enterprises in your country. After looking carefully at the units that you want to collect data for, then you need to make sure that you have the correct URLs to their website. That the URL is a uniform resource locator, shown as an example here. You want to make sure that the connection with the unit you identified and the URL of the website is correct. And that might be challenging because depending on how your business register is set up, might be challenging to find the correct association level of your URL with the units in your business register. There are various ways to obtain these URLs. In the Netherlands, we are lucky at the moment because we can just ask our maintainers of the business register for a recent update of the URLs associated with companies, and we get a list of them. If that's not available yet, then you have to look or reuse any existing lists created by others. You might decide to buy them from others. Some commercial companies offer something like that, or some governmental organizations might have that. Or you could decide to use the web to find URLs in another way by using URL finding approach. For instance, if I want to know what the URL of Eurostat is, I just type in Eurostat in Google, and the first link that they provide is a link to the webpage of Eurostat. The third step is scraping actually web pages. URLs refer to such pages, but scraping can be done in various technical ways, and the technique you use or the choice you use may affect if a web page can be scraped or not. But there are other reasons as well, and that makes web scraping so challenging. Not all the URLs you would have, even if you have recently updated all URLs, may refer to an existing domain. The domain may not even longer be active. Not URLs will respond, so you try to visit the web page, but it doesn't react. There's no handshake going on, or the URLs might not even refer to a valid web page. And all those situations result in the fact that if you do scraping, you always end up with less pages than the number of URLs. And this is an example of a study done by Jacek for Poland. The size of the population was 503,700, and that was all those units contain a web page because that's the data set he chose. He chose a data set on which, for all the units included there, a web page was a URL was present. If you looked at the unique URL names, you can see that 91% of them were different, which means there's a small overlap between some of them, which might indicate, and it's a nice example that illustrates that multiple companies might have a similar web page or the other way around. All those combinations occur, but that number is fairly high, so that's a good sign. But after scraping as good as possible, he found out that he could only collect web pages from 74% of that original population, which means 26% of them did not result in collecting a web page for that URL, and it might have multiple reasons. That might be because the website doesn't exist anymore. It might be because the website just didn't respond, or it responded that there's nothing there at that point in time. However, there are additional reasons as well, but I'll discuss them when I talk about the 11 web scraping issues we have identified during our studies, which are shown on the next slide. And these are the first 7. And the first two of these items sort of result in a similar effect. You have to make sure that if you start scraping, that you try to update the list of URLs as make it as recent as possible, because the web is a very dynamic environment, and companies quickly change their URLs. A company might no longer be active anymore, so things are not always correct. So you try to update as correct as possible to make sure that you have collect the right information from a website. Some websites are not updated very well, so you might have non-recent data on a website. We try to solve that by regularly scraping in and see if there's any difference. A lot of websites are actually blocking robots. This certainly happens when you write a script in R or in Python and you try to access such a website directly. And Jacek nicely demonstrated that if he changed his scraping method by not scraping a website directly from the Python language he used, but using a headless browser in between, the number of websites he could actually scrape or collect data from increased from those 74% to 84%. So that was a difference of 10%. Still, 16% of those websites did not provide any additional information, and that's a combination of websites that don't exist or do not react to that. If you scrape a website, you always have to check if there's a robot.txt file. That's something you have to particularly look at. It may be indicated in the text file that the owner of the website doesn't want you to scrape it, and that's something you have to inform the website owner of, because we believe that for official statistics this should be allowed, because it's really it reduces the administrative burden. What often happens during web scraping, if you start collecting data, some websites don't respond. And that doesn't always mean that that website is not available. It might be a temporary unavailable website. And we solve that by regularly visiting that website at later points in time, for instance, the next day or after 4 days at different times, and try to rescrape the website. And often it makes a difference of a few percent of additional websites that can be collected. That's a way to solve that issue. And the 7th mentioned here is the fact that what you actually want to know is how recent the data on the website was. So you try to check for timestamps or a time indication on the website to see at what time that data was produced. But if that's not available, then you, by regular scraping the website, you can monitor those changes by looking into whatever storage you have. Points 8 to 11 are indicated here. Nice example of duplicates, as mentioned by Alexander before. You probably start with a unique list of URLs, so you don't want any duplicates there. But often a particular domain name might, if you visit that site, might refer you or redirect you to another website. And that might result in even though the URLs you had in the beginning were unique, in the end you might have duplicates of websites included there. What I always do in a scraping session is that I know the site where I start, but I always store the URL of the site I will end up with, because a lot of those URLs might send you to another location on the internet, what you call a URL forward check. So store the location you end up with. Sometimes a website that provided you with a lot of information returns only limited information. That means something is going on. For instance, one of the most obvious things that might happen is that a website is no longer being used by the company, but it reports website for sale or domain name for sale. So that's something you need to check. But it might also be something else that's going on. Perhaps the company has changed the products it's selling or changed its activity. Another very important point is the quality of the link between an enterprise and the URL. You have to make sure that you're collecting the correct web pages from the company that you originally wanted to have information from. And you can check that afterwards by comparing if there's any information on the company, like the name or the address on the website. It would be great if the Chamber of Commerce number is on there on the website, but not every website contains that information. And the last thing I want to point out is that you always have to realize that not all companies may have a website, and it might be relevant for your study to also have an idea of how many companies don't have a website. Sometimes that's obvious, but sometimes, for instance, for the innovative company study we did, you would expect that every innovative company would have a website, but we actually found out that 0.1% of all those companies did not have a website, and that's something you need to include in your further studies. So that's the overview. Certainly, in my opinion, and I think a lot of people agree with that, is that the web is a very interesting source of data, or an additional sort of data. And the interesting thing of using web data is that you're in control of collecting your data. A lot of new data sources that contain data, and you have to deal with the data as it is. You can't change anything, but in the case of the web, you're at least in control of the data collection process, which is really great. There are many applications for which you can use web data. Consumer Price Index is an example where you scrape product prices. Real estate has been mentioned. Of course, vacancy statistics and collecting online job advertisements as additional data sources. Actually finding websites and URLs is a way you can use that. And also, that's a application that I'm really involved in our office, is identifying subpopulations of enterprises. So you start with the whole population and try to focus on particular subpopulations that you will investigate further by any other data collection means. And of course, it's a way to obtain satellite pictures. Methodology is needed to deal with data collection and quality issues as good as possible, because in the end, you want to produce the best statistics as possible. One of the things we will focus on later on is the difference between general and specific methodology. And I have to find out how I can stop sharing my screen. Thank you for your attention. And
Thank you, Pete.
And now I have to refer it back to you, but I'm lost here.
I can try.
Yeah, that would
my
be
screen.
Nice. Yeah. Okay. No. For some reason, that seems to, something is happening. Thank you.
I share my screen and now I'm stopping again.
Great.
Okay, now nobody's sharing the screen. Yeah. Okay. Thank you, Pete, for the presentation. Thank you, Pina, as well. Very interesting. We already have 2 comments. I will just start with the first one by Sonia. Thank you, Sonia, for the thank you and for the comment on the quality of the presentation. So the question is basically starting here. How do you see it going further, for instance, on the example of studying coverage or coherence? So it's about the quality aspects and the connections to the user stories. Pina, do you want to start, or should I say something first?
No, I would say that it could be a very good way to proceed in order to understand the specific issues of each use case, and try to understand whether from common tasks, common issues such as coverage or data coherence, it's possible to add some components in the platform that allow to do these tasks in a simpler way, and sharing the methodologies so that we can try to find connections between methods and the use cases, because I think that these are issues that have to be assessed for each use case, although they are different. They concern different types of web data. For instance, also the comparability with external auxiliary data sources is a common issue for all the use cases. So this could be a way to proceed. Thank you, Sonia, for this question, because it is real, how could I say, it helps to have an holistic approach, architectural, methodological, and I think this is a good start.
Thank you, Pina. But I also think the issues are of different maturity, basically. So for over coverage, a big part is this duplicates, deduplication, and there is quite a lot of experience now already to how to handle that. For the other side of coverage, under coverage, I think there's less experience there, and it's not it's also a problem we of course have, as Pete mentioned in his presentation, that there are innovative companies who don't need a website, obviously, and if we have to want to have them in our estimates, we also have to handle this under coverage problem more systematically. So I think the different quality aspects and also like sub themes of the quality, different quality aspects are quite different in the how far are we in development of like a common understanding of the problem and of the solution, of course, as well. Would you agree to that, Pete?
Oh yeah, yes, I agree with that. The example you mentioned, I was surprised actually that we found out that not every innovative company had a website, but it was actually in the response of the survey. It was also obvious that we couldn't find websites for all the innovative companies. So that's something that needs attention. It isn't a lot, but it's something you have to be aware of.
Okay, so the next question is from Rita about how can we ensure privacy preserving data analytics in the global scope of quality in the phases of access to the data and treating data. So from my perspective, I mean, it's quite easy for web data, because there we only use kind of publicly available data from the web. The story is, of course, quite different if you look at other privately held data sources such as mobile phone data. So there are some privacy related issues. For example, we are not allowed to use Google for finding URLs for persons, but for companies. There's the distinction there, and there are of course a lot of companies who are just persons. So this single person companies, I'm not sure if that's the correct English translation, but like just one person running like a small company, freelancing, and then the company name is the person's name. So in that case, we're not allowed to just use Google to find the URL. So there are some aspects that are privacy related with web data, but in general, I would say it's not such a big issue. If you are processing at the premise of a data holder, of course, it's you are in need of methodology of data analytics that handle that as well. And it's important to still have a view on the quality of the processing and not just describe how it should be done, and then it's done by another entity and you get the resulting data without any quality checks. So it's a tough thing to do, that it's also auditable and things like that. Are there other comments from Pete or Pina to the question about privacy preserving techniques?
I only have a question to you, Alex. You are allowed to use other search engines apart from Google, or
No.
No? Oh. But for businesses, oh no, okay, yeah, that's challenging. Yeah.
I mean, we have other sources for URLs, but not so the. I think the chamber. So there are other sources for URLs in the business register than just Google, but we are not allowed to look for them. I'm not a legal expert, something with GDPR and stuff, but it's also about how you interpret it, I guess. So we have another question from Sonia. Thank you, Pete, for your presentation on the challenges of web scraping, which is just a starting point. In the next presentation foreseen for January and February, can we expect to go further in the methodological challenges, specifically with OGA data?
Yes, of course, because that's part of the OGA data is a large part of the WIN project, so we should have a look at it. I think one of the other challenges is, but now I'm probably a bit ahead of what we're doing, but a lot of the if you do a lot of textual analytics on the website, you use machine learning methods, and there are huge challenges there. If you look at how you can apply machine learning and the results of machine learning classifiers in official statistics, because we found out that they are affected by the assumptions you make in your training and test sets, and we need to deal with them as well. So. But let's start. That's why I started with the easiest part. Let's start with web scraping as a starting point, and then how you're going to deal with the data you collected. And there are several examples of that, and we will certainly discuss them. I'm not saying to Sonia that we're going to solve everything. At least the most important thing is that we identify the biggest issues and then focus on how we can deal with them.
Thank you, Pete. Follow-up question. Do you also see the connection with the user stories that Pina presented and adding functions to the Web Intelligence Hub? I think there is quite obvious connection between the functions and the methodologies or the methods we apply, I think. So some of the methods probably directly translate into a function. The function might be more a method probably is more specific than a function, but it's closely connected. And I think we are still we are also working on. If you mentioned the classification, we are just had we call it annotation exercise. An exercise on checking how well an algorithm performed to classify job adverts according to the occupation classification. So that was done by I think all the countries in this Web Intelligence Network project. And I mean, initial results are not really satisfying, let's put it like that. And there is also like a work stream, not just in improving the models, but also we discussed if we have to improve classifications or make classifications fit for that purpose. So that's the history of most of the classifications are like questionnaires, so they should be easy to be filled out, or like jobs should be easy to be classified with a questionnaire, but that's the same logic is not transferable to it's easy to be classified with a model and work in this this direction. Basically, it just started how a classification should look like to be easily or most accurate to be classified with a machine learning algorithm. So a lot of fronts where we need to make progress.
Some of them sound more like that it's good to have an overview of things that work, to get an idea of the best practices. What are the most interesting results you can find, and then they might not solve everything, but but at least you have an idea. Okay, this is the best approach available that we have identified so far. I think that's a good point as well. Thank you for mentioning it.
Yeah, thank you. We would have a few more minutes if anybody has a last question or questions following up on the discussion. We'll just wait for 10 seconds if something is coming in. Okay, without having a watch with seconds on it, I think 10 seconds have passed. So thank you very much, all of you, for joining the webinar and listening to our presentations. I will now hand over to Sarah for closing this event.